Okay, so I also want you to think about voltage in a slightly different manner. Now, this is not different to the explanation we learned about earlier, the pump explanation. It's really just the same thing, but it makes a lot easier to visualize a particular concept that I want to explain. And then we can easily relate it to the pump analogy. Okay, so think about how can you make water flow, right? To my mind comes two very really quick answers. One, I could have a pump, and number two is I could have two tanks that are different that are separated by a height, right? So the weight of the water is actually making it flow down to the pipe, right? Now, here's the thing: I can have a huge height difference, or I can have a really small height difference. Now, what really is the determining factor is the gradient through which the water is flowing. And you can clearly see that the gradient over here is much more than the gradient over here. Now, what's going to happen when the gradient is more? Well, when the gradient is more, you're going to have much more water flowing through this than through this system. And that's what voltage is. You can have a higher gradient, that means more current can flow, or you can have a lower voltage, that means, or a lower gradient, that means a lower current will flow, right? Now, this makes it very, very easy to grasp a certain concept because voltage is always measured between 2 points, right? You're always going to be measuring voltage between 2 points. So you need this point and you need this point to be measuring voltage across them. That's really what is required. And why is that really required? Because what you're measuring is this gradient. You're not measuring how much water is in this. You're not measuring how much water is in this. You're actually measuring the gradient. And to measure the gradient, you need to measure it between 2 points, right? So this point that is at a higher level can be thought of as the higher potential. This is a higher potential point, and this point that is at a lower level is a lower potential point. And how are you going to get the value for the gradient? Is the higher potential minus the lower potential. That's how you're going to get the gradient. And that's what voltage is. The voltage is always being measured through 2 points, across 2 points, because what you're measuring is the higher potential minus the lower potential. Now, why did I really want you to grasp this concept, and why do I want to relate it to the pump analogy? Now, the pump analogy, a lot of people only think that voltage is really just across batteries, right? No, that is not true. The voltage is not just only across batteries. It's easier to think of this as like the battery, and this is the battery that is pumping the water around. No, this pump can be across individual and different components as well. So for example, you have this filament bulb, okay? You do not know the symbols for these. That's not important to know, but just take my word for it. This is a symbol of a filament bulb, right? Now, this bulb will also have a voltage across it. Why is that? Well, you need that because you need to have a gradient. For current to flow, you always need a gradient. So any component in the circuit, any component needs to have this higher potential and this lower potential, and the subtraction between them two will give you the voltage. Right? That's what is happening. So each and every component in a circuit is going to have a particular voltage across it. That's what makes the water flow. Now, this isn't really different to the pump analogy. It's just that it makes this concept to visualize, understand better. Well, the pump is also doing the same thing. You have a point of, let's say, higher potential over here. Well, it's flowing through this. So you have a point of higher potential over here. And you have a point of lower potential over here. So instead of naturally making the water flow, what the pump really is doing is that it's making that gradient artificial. It's using energy to create that gradient. So there's no difference between the two concepts. It's just that particularly understanding it through water tanks and the gradient makes you easily understand why there should be a voltage across each component, because each component needs to drive a current through it. And for that current to be there, you need to have a gradient. As simple as that. I hope this helped, and I'm going to see you in our next video. Thank you.